Hello and welcome to lesson 1.4 over angle measure. We're going to talk about what angles are and how to measure them, how to classify them, and this starts on page 36 of your textbook. If you have not already, make sure you filled out the vocabulary from lesson 1.4 and that you have read through that lesson so you will already have a little bit of an understanding of how these examples work. And here's your content standards and the mathematical practices. We will again be paying attention to precision, and that's one thing we talked about in class on block day this week. In the past, we've measured line segments with a measuring device. Now we're going to measure and classify angles, and we're also going to identify and use congruent angles and the bisector of an angle to perform calculations. So here's a list of your vocabulary, a little bit more with this lesson. Ray, opposite rays, angle, side, vertex, interior, exterior, and those are interior of an angle, exterior of an angle. Degree, right angle, acute angle, obtuse angle, and angle bisector. So let's take a look at example 1 now that we know that vocabulary. So if we are to look at example 1, there are 4 parts here. We're going to use this map of a high school shown. We're going to name things like all the angles, sides of an angle, and look at other ways to name angles and points in the interior. So why don't you take a look at these and see if you can get answers for these, and then we'll check our answers together. You may need to pause the video if you need more time. Otherwise, these are the answers we should get. Alright, we have angles 8 and 6 marked here that are sharing angle K as a vertex, but you could also consider straight angle HKC as an angle. You could have included that also. Now if you called angle 8 HKJ, that means the same thing, or JKH, and angle CKJ or JKC is the same as angle 6. On part B, we should have gotten this. KJ is a ray that makes up one side of angle 6, and KC is the other ray that makes up the other side of angle 6. Notice that K is the first letter of each one. When listing the sides of an angle, the ray must start with your endpoint of your ray being the vertex of that angle. So the first letter we use is K in both cases. If that's not the way you wrote it, you need to recorrect that so that that is the correct way to write that. Alright, part C, we should have gotten this. Angle 9 is another name for angle AJK. You could also call it angle KJA, but this is really the answer this problem is looking for. And lastly, part D, a point in the interior of angle ECG. If you look at angle ECG, the only point labeled interior on the inside of this angle is this point F. Alright, D is on part of the angle, not in the interior, and so we have point F. The flag, if it were represented by a point, could be in the interior of angle ECG also. Alright, we have something called the protractor postulate, which you may not have read in your book, but is a point I'd like to point out in the notes, and it basically just allows us to take measurements of angles from 0 to 180 degrees. We can set up a line, AB, and point O on that line, and from point O we can draw a ray for each degree from 0 to 180, and it's what allows us to come up with a protractor. Like this, we have a protractor. This bottom line here would be line AB, and we have point O at the center, and I could draw all these rays, 180 of them, and get our measures. So we're going to need to use a protractor in a little bit. We have some types of angles we need to identify. Okay, an acute angle is any angle that measures between 0 and 90 degrees, not including either one of those. If it measures exactly 90 degrees, we call that a right angle. If it measures greater than 90 but still less than 180 degrees, we call it an obtuse angle. And a straight angle is formed by two opposite rays. Okay, they share a vertex, and then the non-common sides, or those rays, form a straight line. So we're going to measure and classify angles here. First thing I want us to do is classify angles A, B, and C according to this diagram, but then we are going to measure them with our protractor. Notice you might have to extend these, so if you don't have a protractor, we can handle this part in class. I've got some you can borrow, but it'd be a good idea to pick one of these up. They're not very expensive, but they're going to be a great tool in the rest of this chapter for measuring angles. So let's take a look at classifying these angles. First, let's look at angle ABD. Angle ABD, notice the middle letter is always the vertex, so if you want to trace it, that's this angle here, which has this marking. This marking means that that is a 90-degree angle, so we know that that is called a right angle, and I don't even have to measure that to write that it is 90 degrees, because I know it's a right angle by that marking. Next, let's look at angle ABC. ABC, notice C extends above ray BD, so that means that angle measure has to be less than the full angle ABD, so that must be acute, and we'll measure that in just a moment. And lastly, let's look at angle ABF. ABF, notice this is below ray BD, and so we've got our 90, but then we keep going if I measure my arrow around this way, and I get greater than 90 degrees, so I know that that is obtuse, because it's still not a straight line. So I wouldn't call it a straight angle yet. Now let's measure those and just verify that those are in fact acute angles and obtuse angles there. Alright, I've brought in a little bit smaller protractor that I have printed out here. It's a little bit easier to manage. Okay, so let's first look at angle ABC. ABC is that angle, and here's how we measure this up. I'm going to line B up with our vertex of our protractor, and I'm going to align this bottom edge with one of the rays. I can measure it this way, or I can turn it around and measure it this way, and this might help us. And you can see ABD is a 90-degree angle, so we had that one right. Let's look at ABC. Notice if I extend this direction, I'm between 40 and 50, not 140 and 130. Notice 140, 130, those are obtuse measurements, and I'm measuring an acute angle. So I'm going to say that if I extend it, it's right at 45 degrees. Now let's measure ABF, and again I'm going to measure it this way. And there's F, and if it keeps on extending this direction, we're right there between not 50 and 40, but 130 and 140, and we are more than halfway from 130 to 140, and so there's 135, 136, 137, we're at about 138 degrees. And again, extending those lines is going to help us see that even better. I'll use my bigger one here to show you. In this case, we look to be about 136 when I extend that line, and that's okay. If I want to call it 136 instead, I can. As long as you're fairly close with your measurements, you'll get points. Alright, when we look at angles that have equal measures, we would say the measure of angle ABC is equal to the measure of angle DEF, and this little m before the angle symbol is how we would read the measure of angle ABC. And the measure of angle DEF. If I don't have the measure symbol, I'm talking about the angles themselves, not their value. I say that they are congruent. If two angles have the same measure, then they are congruent. And so that's how we fill that in. Since the angles have the same measure, then the angles are congruent. And this is how we mark them. We use arc marks to mark angles congruent. If I have two different angles marking them congruent, I'll use a double arc or even a triple arc for a third set of congruent angles. So let's take a look at example 3. In example 3, here's what we need to do. We need to find the measure and classify the angles. Here we are told that ABD is congruent to FHG. So I'm going to mark those as congruent angles on my diagram. And we're told that the measure of ABD is 3x plus 6 degrees, and FHG is x plus 26 degrees. If they are congruent, they have equal measures, and so I can say that their measures 3x plus 6 equals x plus 26. And now we just solve the equation for x to be able to find the measure of these two angles, and they should be the same number. So if we find x first, then plug them back in, we'll find those angle measures. Why don't you take a minute or two to find the value of x, and then we will continue. Alright, if you need more time, which you probably do, go ahead and pause the video, otherwise this is what we should get. Alright, if you'll notice when we solve for x, we get x is 10. And if I plug that into both of these, I get 36 degrees for both. But we knew they were congruent, so really we only had to plug them in for one, and we can just write our answer that way. They're both equal to 36 degrees. Alright, now we have something else called the angle addition postulate. You might remember us talking about the segment addition postulate. If I have S that's in the interior of an angle, the ray connecting the vertex to that point in the interior creates two other angles whose measures should add up to the entire measure. So angle PQS, that measure, plus the measure of angle SQR, if I add these two values, I should get the measure of angle PQR, the whole thing. This is called the angle addition postulate. So let's apply that in example 4. Here we are given this diagram. You'll notice F is in the interior of angle DEG, so that means that the sum of this angle plus this angle should equal the total measure of angle DEG. Well, they tell you that measure, DEG, is 115 degrees. But they also tell you that the measure of angle DEF is 48 degrees. Well, that's enough for us to find the measure of angle FEG, because remember this, the measure of angle DEF plus the measure of angle FEG should equal the measure of angle DEG. And then it's simply plugging in the things we know. DEF measures 48 degrees. FEG is our unknown, so I'm going to leave it as the measure of angle FEG. And we know the total angle measure is 115 degrees. And then it's simply subtracting 48 from both sides. So the measure of angle FEG is the difference of 115 and 48. Which is 67 degrees. Don't forget the degree symbol, that's your unit of measure. Alright, let's take a look at example 5, but first, let's talk about what an angle bisector is. An angle bisector is a ray that divides an angle into two congruent angles. So JK is our angle bisector. So we know that angle LJK and angle KJM are congruent angles. So we can use this fact to help solve equations and find answers to our problems. So here's what we have. Part A, we are told that KM bisects angle JKL, and the measure of angle JKM is 4x plus 6. So for part A, we're told that JKM is 4x plus 6 degrees. And that MKL is 7x minus 12 degrees. So we're supposed to find the total angle, but we know this is an angle bisector, so these are congruent. So that should tell you these expressions are equivalent. Then I can say 4x plus 6 equals 7x minus 12. So all we have to do at this point is solve for x and plug it back into each one to find our total. So pause the video to give yourself enough time to solve for x. Alright, we should get this. X is 6. Okay, when we solve this, we get x is 6. Now, all we have to do now is plug x into each one of these. So if I did 4 times 6 plus 6, that's 24 plus 6, which is 30. Okay, on the other hand, if I did 7 times 6 minus 12, that's 42 minus 12, which is also 30. Now, if I wanted to find the total measure of JKL, not JKM, it'd be 60 degrees, but they ask for JKM, which is just one of those, so that's 30 degrees. All right, I'm going to let you try and do part B, but the first thing you should do is draw the scenario that QS bisects angle PQR. And then we can fill in what we need to know. So fill in the pieces and see if you can find the measure of angle PQS. Alright, this is what we should get. We should get 34 degrees. Make sure you notice that they tell you PQS is 5y minus 1, and the whole thing is 8y plus 12. And so we don't want to set these two equal. We want to say this plus itself, or 2 times that is 8y plus 12. And that's how we get that answer.